In this video, we're going to do a guided example. So we're going to work together to graph this transformed version of the function for cotangent. Okay, so that's what we're going to work on right now. All right, so cotangent, we want to first make sure we remember what the parent function looks like. So y equals cotangent x. I'm going to sketch a little sample of it right over here. And then y equals, I'll even do negative cotangent x because we hadn't talked about that yet in the actual lesson video. And then I'll draw a little sample of it over there. So that would be 2 pi. In the middle, I'll have pi over 2, and pi over 4. Kept cutting in half. Then that's 3 pi over 4. In between is 3 pi over 2. And then we have the other pi over 4s in those two middles. So 5 pi over 4 and 7 pi over 4. So I even mentioned in, I think, one of the last videos that we just went over, but the lesson for cotangent, the more we spread out this axis over here, crooked, the more we really make this part long, especially for tangent and cotangent, the better, because you have 9 tick marks on tangent and cotangent as opposed to just 5 for the other 4 for sine, cosine, cosecant, secant. Really spread that out so you get a better look at it, Now, I just wanted to make it about the same size, so but I won't though. I was going to try to make them to scale so that they were similar, but I think it's better if I even just show even this one slightly more spread out, what a difference it makes. So there's 2 pi somewhere in the middle. Pi over 2, 3 pi over 2. And then these are the pi over 4s, all in the middle of each of the quadrants. 1 pi over 4, 3 pi over 4. All odd numbers with it, because otherwise it would reduce. It wouldn't be over 4. 5 pi over 4 and 7 pi over 4. Okay. Then we talked about in the last video putting 1 and -1 pretty close to the x-axis for these. It helps us see our inflection a little bit better. And then again, 1 and -1. Got my y-axis. That's all we need there. And my x-axis, a little squished, but it's here. Okay, and I'm just gonna fix a little cut here so you can see a little bit more of the desk. Okay. All right, now cotangent is undefined on the sides. What's on the sides? 0, pi, or your view, 0, pi, back at 2 pi, undefined. And what's undefined look like on a graph? A vertical asymptote. So cotangent is undefined at 0, at pi, and again at 2 pi. Same here. Even if it's negative undefined, well, still undefined. Negative undefined, still undefined. And there we go. That's there. Then normally tangent is undefined on top and bottom at pi over 2 and 3 pi over 2. Cotangent is the reciprocal of that. What's the reciprocal of undefined? The reciprocal of undefined is 0. So cotangent is 0 at pi over 2 and 3 pi over 2. So I'm going to have little green dots right over there. It stinks that I had that white out. Kind of ruins it. And then here as well, because -0 is still 0. Next, cotangent. So even if I made it negative, that didn't impact my asymptotes or my zeros. The next thing is pi over 4s. Cotangent of pi over 4, thinking of the unit circle. This is the unit circle somewhere here, right? So for you guys, this is 0, pi over 2. Where's pi over 4? Right in the middle. What are tangent and cotangent equal to right in the middle? It's equal to 1. Opposite over adjacent. It's a 45-degree angle or a pi over 4 radian angle. 44, 45, 90, pi over 4, pi over 4, pi over 2, whatever. But it equals 1. So right there, I'm at 1. So it's 1 unit above the x-axis. And then at 3 pi over 4, that's down in quadrant 2. So keep going. 1 pi over 4, 2 pi over 4 is pi over 2, 3 pi over 4 is over here. Your opposite over adjacent is now negative. So it's just a negative 1. So it's almost like the amplitude, 1 unit above or 1 unit below. And then as we hit pi, the thing with, I have to go this way. As we hit pi with both tangent and cotangent, we've already hit every possible answer and pattern and sequence of answers, and they're just going to repeat the same cycle again. So instead of the period being 2 pi, like it is for sine, cosine, cosecant, and secant, instead of it taking a full circle for you to repeat the same numbers in the same order again, for tangent and cotangent, we hit those same numbers after pi. So 0 to pi, everything we saw here repeats exactly the same underneath from pi to 2 pi. And again, it repeats until 3 pi, repeats again until 4 pi. So the period is not 2 pi over b for tangent and cotangent, it's just pi over b. That's the big change. So here, this second piece is going to be the same, up 1 unit and down 1 unit. So up 1 and down 1, and then I just draw, and that was a 0. I draw like this little scoop right over there, kind of like a half of a parabola. But then here, my scoop is going the other way. So it really looks like a cubing function. And same idea there, because it's 2 full cycles that we see. So with tangent and cotangent, when you graph it, we see 2 full cycles. We're graphing 2 periods because we have a shortened period. It repeats itself faster, okay? Same idea now, but negative. So instead of it going up when it goes up and down when it goes down, well, reflect it. It's a vertical reflection, makes everything opposite. So these are going to go down a unit at the other spots and up a unit. So we have those little shapes right there, and we're going to draw it kind of shaped the other way. So here we go. And there we go. Okay. That is cotangent. I know this looks a lot like tangent. It is not tangent, not tangent, okay? They're asymptotes and the zeros are in different places, makes a big difference. So let's talk about this example. First thing, usually what we end up doing first is, I think it's a good idea, in blue I think I've been doing every time, I draw my sinusoidal axis. In this case, I have plus 9, so I am moving up 9 units for the midline or the sinusoidal axis. So I'm just going to go right there. And I'm going to go ahead and label that y equals 9. From there, what I'm going to do, so now that we have y equals 9 right there, the next thing I like to look at is this over here, my a value, which is 3, or in this case, negative 3. And the 3 is telling me that this little orange and orange is going to be 3 units either above or below. Since it's negative, it's going to be that shape that we see over here. So the negative is telling me that we're more concerned with this one over here. What else do I know? Well, if that's 9, then I need to know basically a tick mark for 6, 3 below it. And I need a tick mark for 12, 3 above it. And because these are all positive, my x-axis is going to be below somewhere. So I'm just going to go ahead and I could fill in my x-axis. Again, the wider we make it for tangent and cotangent, the better, because you have way more tick marks and a lot more stuff to have to label, and you want to make sure that it's not too cluttered. Now, if that's going to be the whole entire space I'm giving myself to graph it, what I do is I put the first and the last. Then I'm going to put the middle. That's a 3rd tick mark. Now I'm going to find the middle of each of those. That's a 4th and 5th tick mark. If we were only doing either sine, cosine, secant, or cosecant, we would be good with tick marks. Tan and cotan, we're going to double it up, another midpoint for each one. So one more here, 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 and here. And it approximately makes them all about the same size when we do it that way. So there's my x-axis, bunch of tick marks, doing good. So what do I want to label now? I can draw my graph even without labeling. I always have an asymptote on both ends and the middle. End, another end, and then the middle. Make sure you count correctly. And then I have a 0, or, you know, that point of inflection in the middle of each of those spots. The negative cotangent has this shape. So here I'm going to be up 3 units at 12. Here I'm going to be down 3 units at 6. And same idea, down 3 units at 6 and up 3 units at 12. And then it's concave down on that side. And same here if you wanted to draw this part first for both of them so you make the shape the same. And then over here, concave up. Really, it's going to get closer and closer to that dotted line, but I'm not going to overlap right there. And then same idea here. In these, the lower we kind of put that point, the easier it is to kind of let it get close, but it's all good. What else can we put on here? So let me just mark off everything I've taken care of. So the shape of negative cotangent, I basically have taken care of that. I took care of the blue sinusoidal axis, which was the +9. I took care of the 3 in the picture. The 3 is this far apart, 3, and this far away here and here. Now I would take care of the x+6, so that's going to move me to the left 6. So this is a -6. I put the tick, like the fake, these are fake numbers, after it so it wouldn't look like a negative, if that makes sense. So this being a 6 is talking about that, and this is a -6 here. Now that's a little unusual that we have a -6. We're probably used to seeing pies there, but hey, number's a number. You can't be mad. It tells you go left 6, you go left 6. Now that that's done, that's what we were marking in pink, our H values. I was using pink for that. And I was putting a dashed line, but here I have an asymptote anyway, so it's a little redundant, but you can get a double tick mark there. I mean, a double dashed line. So we took care of the +6. That was left 6. So now the pi over 20. Over here, I suppose, period for tangent and cotangent is just pi over b. In this example, b is equal to pi over 20. If we fill that in for the b value, you'll get that the period equals pi over 20. When we divide by a fraction, you multiply by the reciprocal. So the period equals pi over 1 times 20 over pi. Adios pies, the period is 20. That kind of makes more sense now since my starting point was a -6. Well, my period doesn't have a pi in it either because this had a pi, so it kind of crossed out and reduced and simplified out. So the period, if I just rewrite, period is 20, and the quarter period is 1/4 of the period, then it's 1/4 of, if it's called a quarter, it's still 1/4. I don't care that it's pi over b. If it's, you know, your first name, it's still a quarter is a quarter. So it's 1/4 of 20, and even just using your brain or math, whatever, do that and you can reduce, you should get that the quarter period is 5. So that means we're going to add 5 as we go along. And remember, we're graphing with tan and cotant. We graph 2 full cycles, not just 1. So we're going to add 5 a bunch more times. So -6 plus 5, this next tick mark would be -1. Plus 5, we get 4. Plus 5, get 9. Plus 5, 14. Plus 5, 19. 24 and 29. And then last we get 34. So that should be correct, I believe. So if you think about it, how far apart, you wouldn't do -6 to 34. How far apart are they? I told you guys we could check, like if you do last minus first, you should get the period. But if you did last 34 minus first negative 6. That becomes 34 plus 6, and that's 40. That's not the period. That's 2 times the period, because if you think about it, we graphed 2 full cycles. So if that's double, well, then we're still looking pretty good, because 14 to negative 6, they're 20 apart, and that should be correct. I guess the only other thing I should put in is my y-axis. So I'm going to put that right over here. Unfortunately, I draw all over this, so I apologize. It gets a little messy, but that's why it's better to follow along and write with me instead of like just watching and then trying to add these details after. It's just like a big crazy mess afterwards to try to figure out how to copy everything. So I'm just going to circle these numbers because they're labeled. That's 9, 6, and 12. I mean, I could white these out just to get them a little out of the way. I should have left that, but I'll put it back somewhere. So the blue dashed line as an equation was y equals 9. And I think that's more or less everything we really need, right? Yeah, right? I think so. So that's an example. In this guided example, our x-axis did not have any pi's on it, only because my b value did have a pi in it. When we did all of our work, pi eliminated, and we had this cute x-axis that had all integers on it. On your own, I want you to do the following example. Let's do y equals 1/4 cotangent. Let's do 3/8 x plus trying to do it in my head a little. And should I be nice? I could be nice. 11 pi over 6 plus 5. So you're going to graph 2 full cycles of that. Label everything. You should have 9 x-axis tick mark labels, 3 numbers labeled on your y-axis. Ooh, you know what we should also, I have an idea though. We should start doing. You can label the equations of the vertical asymptotes as well. If it's an x in the equation, then it's an x-axis. So we could also acknowledge that this is the line x equals -6, which it is not allowed to equal really. This is the line x equals 14. Vertical lines are always x equals. And that is the line x equals 34. I think it's just important to remember y equals something is a horizontal line, y equals 9. X equals something is a vertical line. So we're just describing our asymptotes. So you should have, for cotangent, 3 asymptotes and 9 tick marks on the x and 3 tick marks on the y. All right? So if you follow that last one, you feel like you will be fairly decent, like 70% or better on this, give yourself a thumbs up. And if you think you'll do worse than 70% on this by yourself, give a thumbs down. And then we know what needs more practice, okay? So good luck on that.